In this lecture, we'll look at those two examples. The first one is to find the exact value without using a calculator for the expression cosine 2 arctange negative 4/3. Now, here is the technique. We know that arctange something is always an angle. Okay, arc something is always an angle. So then we like this one to be an angle, so we like this one to be alpha. Then of course we will have a cosine 2, this one will be alpha. So once you did this thing, you have actually two facts. The first fact is you let alpha equals arctange negative 4/3. That's the first thing. The second fact is that cosine 2 arctange negative 4/3 will be actually cosine 2 alpha. We will deal with that later. So let's see alpha equals this quantity. What do we get? What immediately we can get is alpha will be tan alpha will be negative 4/3. That's immediately by definition. Okay. Now look. Don't forget the picture. Okay. This is the technique we often use. 4/3 is tan alpha. Again, we don't consider the sine first. Okay. Now, if here this leg is 3, this leg is 4, we will have what? 3 squared plus 4 squared is 9 plus 16, which is 25. This gives us what? This hypotenuse is 5. Okay? Yeah, this is Pythagorean theorem. Now, based on that, we then have two things. One is that we have a sine alpha is 4/5. Well, tan alpha is negative 4/3, then alpha is actually negative angle in quadrant 4. Okay, so then here sine alpha in quadrant 4 is also negative. That's one thing. Another thing is that cosine alpha. Cosine alpha is 3/5. That's the value. Okay. And cosine alpha in quadrant 4 is positive. Cosine is positive in quadrant 1, 4. And sine is positive in quadrant 1, 2. In quadrant 4 is negative. Alright. So here, based on the fact arctange negative 4/3 is alpha, we can get sine alpha, cosine alpha easily by using the pictures, Pythagorean theorems. Now another thing is that we say we have two things. Cosine, once you let this one be alpha, you have alpha is that. Another thing is that cosine 2, this one is alpha, so you want to write cosine 2 alpha. So if you want to find out cosine 2 arctangent negative 4 over 3 is, you want to find out this. Okay? There are two things right here. Now, then we will have a double angle formula, cosine alpha squared minus sine alpha squared. Okay? And then cosine alpha squared we know is 3 over 5 squared. Sine alpha we know negative 4 over 5 squared. And that's 9 over 25 minus, you see this is negative 4 squared first. So negative 4 squared is 16, okay, over 25. And then you subtract. You have this positive number, negative 4 squared is positive 16, and then negative. And then the final answer is 9 minus 16, which is negative 7 over 25. Alright, we are done with the first example. Make sure here we separate it. Now, we want to do the second example, which is write sine 2 secant inverse u over 6. Here u is greater than 0. It means u over 6 is a positive number. Basically, it says that. So we want to write sine 2 secant inverse u over 6 in terms of u without trigonometric function involved. Again, this one looks a little bit hard, but you know, the techniques are the same. The difference is that upstairs is a number, here downstairs is u over 6. There is a variable involved. The techniques are the same, is that we want to make this one be alpha, because secant inverse is like arcsecant something is an angle. So we like to do is we let alpha equals secant inverse u over 6. Okay, then immediately what we can get is what? Secant alpha is u over 6. Okay, again secant alpha is, I want to write in the red pen. Secant alpha is 1 over cosine alpha. Okay, this one. So if you flip both numerator and denominator concurrently, so you will then have a cosine alpha. Of course, if you want, you may write over 1, but it may not be really necessary, equals 6 over u. Okay, u is positive again. So then alpha will be in the first quadrant. Alright, now look, use the picture again. That's the important thing. Where you should put alpha, where you should put u. You see cosine alpha is adjacent over hypotenuse. If you put your alpha here, then 6 will be the adjacent right here. Okay, then u will go there because that's the adjacent over hypotenuse. Okay, now by the Pythagorean theorem, this side will be what? Hypotenuse squared, subtract 1 leg squared, choose the square root. Okay, will be this leg. Alright. Now from here we then get what? we then get, you can get whatever you wanted. For example, here we can get sine alpha. That will be opposite side or hypotenuse. So then you then have u minus 6 squared, you may write 36, okay, over u. Alright, so opposite side over hypotenuse. So we have a sine alpha, we have a cosine alpha. We may write tangent alpha, cotang, secant alpha, cosecant alpha, but here we may not really need it. So again, down here, once you let secant inverse u over 6 equals that, you can do one thing right here. Another thing is that the things you want will be secant, let me write here, secant 2, sine 2 secant inverse u over 6. You want this one, right? But you know, this will be sine 2. This one is alpha, as I said. That's the second effect. This is alpha you introduce to yourself. It's very convenient to do in this way. So it's 2 alpha. And now you know you got to use what? Double angle formula. That's 2 sine alpha cosine alpha. Okay, and the sine alpha, cosine alpha are ready for you to use. You see? Right down here, exactly. Alright, so you may just write that will be equal to 2. Sine alpha is the one right here, so that will be radical u squared minus 36 divided by u, and cosine alpha is 6 over u. Okay, and then 2 times 6 is 12, and then numerator is u squared minus 36, and downstairs is u times u, which is u squared. Okay, so again, this one looks hard, but it's not really hard. We have 2 examples right here. One we did was A, and the other was B, but those 2 looks again different. We always have 2 things. One is to let alpha equals that. This is one thing. And then another thing is that originally cosine 2, this one will be actually the one right here. So that's the second thing. And down here is the same. Okay. Yeah. Once you introduce alpha, you have 2 things to do. That's the common technique. Okay. All right. Please review this lecture. I'll see you next time.